No, you're not seeing things. No, this is not a test. Do not pass go. Do not collect $200. Do not adjust your television sets. I got the LED to work nice and bright, as I had hoped. I played around with these 68 ohm resistors that I had, and I managed to get a nice bright color output. Hopefully the resistance is proper, or at least close enough to proper to not burn out the LED while I'm still using it for the lessons. But let me unplug that for you because it's probably annoying in the camera. It's killing my eyes. But welcome to day 9 of my Inventor I.O. 30 Days Lost in Space adventure. Today's lesson is going to cover a little bit more with using the multicolor LED along with the photoresistor that we wired in a few days ago. I watched the video. I have to put in the code, but I wanted to show what I had done to my breadboard here. Again, as you can see, I took 68 ohm resistors and I wired them in series with one another. And when you wire them in series, you have one lead coming out from this side of the breadboard, tying into another resistor, and then that resistor plugs into the side of the breadboard that has the LED plugged into it. So they're just, I'll show you. See, they're just twisted together for the time being. And because one leg goes in, passes through the two resistors, and the other leg comes out to split sides of the breadboard, we get the 5 volt coming here, one resistor, two resistors, that cuts the voltage down. But it cuts it down less than the 220 ohm resistors, which were too much for the LED, and it was cutting too much of the current, and I wasn't getting a good result in my color output. So let me go to the computer view and we will go over the code once I get it crunched in and tested to make sure that it works okay. And I will explain what each of the sections is doing, and we will see you there. The first thing you'll notice is that on day 9 the schematic has not changed. They do have the two solutions that you would use for your common cathode or your common anode on your multicolor LED. I know that mine is the common cathode, so I use the top diagram here, and I will use the top code here. So after watching the video, typing in all the code, and doing the entire video of the description, I then realized that after somebody had asked me to do a screenshot for them, I forgot to set the screen recording software back to full screen, and here we are a few days later finishing up this video. So what the lesson is showing us is incorporating the programs from the 2 prior days, day 7 and day 8, into one program to where we can monitor the amount of incoming light on the photoresistor and apply that to the multicolor LED so that at different stages of charging we would get different color output down inside of here. There was another thing that was gone over, which was creating another function, but this function was different than the other functions that we had built prior, because this one is a double function and it returns an actual value. In the case of this double function, it would return a decimal value, and the decimal value that it returns is the calculated percentage of charge based on battery level divided by battery capacity times 100. So to show that a little more clearly, I'll open up a new session. So at the very top, we initialize our global variables. So the first two are for the analog input of sensor pin, and the integer sensor value just establishes sensor value, base value of 0. Then from there we define our output locations. We'll do the unsigned int of battery capacity equals 50,000. And if you remember in the video where I mentioned the unsigned integer values, I said 64,000 was the maximum. It's actually just over 65,000, but what's 1,000 between friends, right? And then battery level just establishes a baseline value for the battery level. Actually, this integer pot and integer pot value is just me playing after I recorded the previous video, so I'll just leave those out. After that, we create a void function of RGB color, and then inside of that we pass variables called int red underscore value, int green underscore value, and int blue underscore value, which will just assign values back to the output pins. And just as a side note, if anybody's familiar with the Siemens 840D control, I mean really left field, but just something that dawned on me after doing this function with the values inside of here. If you're familiar with the Siemens 840D, whenever you create a user cycle or you use one of the cycles that they create inside of the software, you'll see something like cycle 83, and then inside of parentheses you'll see a bunch of numbers like that. And then even the comma separators with nothing inside of them, you will see those as well. And it just kind of dawned on me that their logic or their cycles are kind of like functions that are written in C, where in the case of this function we would have RGB underscore color and then 12, 250, and 55, something like that. So it's very, very similar in scope to what a cycle looks like in Siemens G-code language. So we create this double function called get battery percentage. We're not taking in any variables, we're just returning variables. And we're returning double battery level divided by double battery capacity times 100. And again, remember that here we create an unsigned integer value of battery capacity and an unsigned integer value of battery level, but down inside of this function we're actually converting those two variables from integer to doubles. So that's an interesting little trick. I'm going to have to try that with classic ladder software that gets used with Linux CNC, because Linux CNC will pass floating point values which are decimal values, into classic ladder, which is written in C language, but classic ladder doesn't recognize floating point values. It only recognizes integer values. And I had a discussion with Chris Morley from the Linux CNC group, and he had mentioned that to me. And now that I am playing with this a little bit, I'm going to have to download me some open source classic ladder code and see what I can do to break the source code of that thing. In our setup, we've got pin mode, red, output, pin mode, green, output, pin mode, blue, output, and our serial dot begin 9600 for data transfer rate. In our loop, we set sensor value equals analog read on sensor pin. The pot value, again, was something that I was toying with. Don't worry about that. I plugged in the potentiometer that I had, and I was just playing around trying to get the colors to kind of increase and decrease with the pot value, along with changing color as it counts. I still have to get that to work proper. That's gonna be my day 10 video, actually, or at least part of it. And remember, this plus equals in our battery level plus equals sensor value. That is shorthand for battery value, or battery level equals battery level plus sensor value. So it's just this equals this plus this. And that's what the plus equals denotes. And then we create a double called percentage, and we tie that to get battery percentage, the function that is up here. So we're returning the calculated value from here to this double percentage variable here. And then underneath that, we just have some if conditionals. So inside of this if conditional, if the percentage is greater than or equal to 100, we set the RGB color to green. But inside of here, we also have an if buried inside the if. So we have a two-level if statement. And we say if the percentage is 100, not only change the RGB color to green, but also check to see if battery level is greater than or equal to battery capacity. And if it is, print out fully charged. And then we'll say battery level equals battery capacity. But then, because of the way that the math is calculated, it may overrun a little bit, so we force feed the percentage variable to be 100. Because down in here, we're printing the percentage, so as it cycles back around, it may count over 100. So we force the percentage variable to be 100 so that it always produces a 100% fully charged instead of 101.8 or something like that. After that, we just incrementally change our light outputs with these else if statements. So you could say else if percentage is greater than 25 and percentage is less than or equal to 50. RGB color will be 125, 125, and 0, which gives us a yellow, because red and green put together will make a yellow. And we say if the, or else if the percentage is greater than 50 and percentage is less than or equal to 75, then RGB color will be 125 red, 0 green, 125 blue, which will give us purple. And then under that, I'll say if the percentage is greater than 75 and percentage is less than 100, not less than or equal, because equal is going to be green, then we'll just output RGB color of no red, 125 green, 125 blue, which will give us a turquoisey kind of color. Or I could just say straight blue and then change from blue to green, but the 125 gives us a nice little turquoisey color. And underneath that, we'll serial print percentage, and then we will serial print line the percent sign. Where are you? With a delay of 200. And again, if I wanted to put the delay up here, I could just say int delay time equals 200. Then down in here, replace the 200 with delay time. See if we have any issues. I'm missing semicolon, which is not uncommon for me. And that was the only error message that I saw. So I will upload this sketch. I will go to my serial monitor and we can watch the percentage grow. So I'm going to upload that again and watch it because I'm not seeing red. So something in my code is not correct until it gets to the yellow. I believe I forgot to put the red. If percentage is greater than 0 and percentage is less than or equal to 25, red, green, blue. Okay. And really it's good practice to learn the proper indentation of all this stuff. I haven't quite gotten there yet. But I'll re-upload. Now I see the red, yellow, purple, turquoisey, and green. So aside from the addition of this second function, the double with the return value, there wasn't a lot of a difference per se, but it's still good to build on previous days just because it helps it set in a little bit better. And I find that recording these videos is helpful for me because it forces me to go back and retype everything and explain in detail what each of these things is doing for you guys. At first I was like, well, maybe it doesn't help to punch in the code and I'll just show you what the code is and what it's doing. But the more I go through it, the more I say, okay, if I type this, it's just doing it more than one time, more than 2 times, more than 3 times, and that helps sync the information in a little bit better. So again, there wasn't really a lot to cover in this lesson, but it was very helpful to merge the 2 days together. And in my subsequent video, it will be helpful to incorporate the potentiometer. That way I can show you guys how we can use the potentiometer values in relation to the LED and the photoresistor and try to come up with some useful little who-dads and do-dads. The recommendation for day 10 is to make a nightlight, so that's where I'm going to start, and I will upload the result in the next video. So thank you for watching. This has been a very long day 9, a 2-day long day 9 if you will. Please be sure to like and subscribe if you're enjoying the content, and we will see you soon.